Okay, there are 3 steps to this. The middle one takes a good deal of work, but it's not a complicated thing to do. All right, so,
Do you think it's easier to write it or do it on the
pardon?
Do you think it's easier doing it this way or on the calculator?
The calculator is probably easier, but I want you to see and understand how it's done, why it's done this way, what you do with it. Yes,
But you can find both the variance and standard deviation in the calculator, right?
that's what she just said.
Okay.
That you can do, well, no, you asked which was easier. But I want you to see how to do it.
Okay, all right.
Okay, and I'm going to try to decide how much of it I want you to do on the test. I may have you still do it where you show me the steps. You can check with the calculator, and then everywhere else you do it, you would use the calculator for it. But I need to see that you understand how it's done. So, we have these numbers. What we have to do first is we have to find the mean. I want you to get used to that symbol for finding the mean. So, finding the mean is just the average. So you add them all up. Okay, so it's 32 plus 41, etc., divide by the 6. And I'll tell you right now what it is. If you add them all up and divide by the 6 of them, you get 72.25. So that's the first step there, is to find the mean. Second step, so I'll put find the mean. The second step, we are going to find the variance. And the variance is often shown with that standard deviation symbol, but it's squared. Now what's good about this is once you find the variance, you just take the square root and that's your standard deviation. So the third step of this will be really easy. This one will take some work. What we're going to do here is we have to find that thing. And what it's equal to is the first number, 32, subtract the average, 72.25 squared, plus the next number, oh, wait a second, we got a mistake, hold on a second.
72, shouldn't it be 38.5?
It should, and that's what I did. I was looking at the wrong paper. I got the whole thing written out here for this one, but I looked at the wrong paper for the average. So 38.5, and I should have realized any of these numbers because none of these numbers are as high as 78, so it doesn't make sense. But 38.5 does, so I need to change that to 38.5. So I'm taking the first number and subtracting the mean. The second number, subtracting the mean, 38.5, squaring it. The next number, 35, subtract the mean. Now, I'm going to do the other 3 in a second, but maybe we'll talk about something. If I had the room, I would just write all 6 here, put a line underneath, and divide by 6. In other words, it's sort of like doing the average. Here, we added these up and divided by 6. Here, we're going to add up this stuff and then divide by 6. That part's the same. This part is what you have to do first. So instead of 32, we're doing 32 minus the mean, and then squaring, this one minus the square. Add all that up, and then we'll divide by 6. So in the case here, since I can't run out, what I'm going to do is I'm also going to do the next one down here. So we'll do all 3 of them, or all 6 of them, and then I'll put the 6 underneath it. 35, oh, there was 35, it's another 35, minus 38.5 squared, plus 46 minus 38.5 squared, plus 42 minus 38.5 squared. So it's basically all of these 6 divided by 6. Now, when you put them in the calculator, 32 subtract 38 is what, 6.5. So that's a 6.5, and if you square it, you get this number, 42.25. 41 minus 38 is what, 3.5, 2.5, 2.5, and you square it, you get 6.25. So you won't have to put these in the calculator because I'll just give you the numbers straight across here. And you can check them yourself later if you wish. But you want to be able to do this yourself because I think I am going to have you do at least one of them where I want to see these steps. When you find the mean, use the mean with each number to subtract, square each of them, add them all up, and divide by 6. So right now, you can copy down what I have, but you can see how to do it. That will be the variance. So it's like A is to do that, B is to add them all up, C is to divide by 6. So 3 parts to doing that. None of them hard, they're just tedious and you gotta get it right where you're subtracting the mean, it's always second, squaring each one of them, and then adding them. No. I will give you a little hint that when I put this as a test question, I use just 4 numbers, and you only have to do 4. So it's not so much. 6 isn't that bad either. But when I first was doing these, I would do them regularly with like 12 numbers, and that gets really tedious. Not hard to do. We use a calculator for each number, it just is a lot of writing. So this, or I'll do this, that the variance, this squared, is approximately 23.6. So that's the second thing, or it says, given this data set, find the variance. We just found the variance. The third thing is frankly really easy. The standard deviation is nothing more than the square root of the variance. So if I want this, like that with a little handle on it, all I need to do is simply take the square root of 23.6. So square root of 23.6, which is approximately 4.9.
And that's the standard deviation?
That's the standard deviation. Now let me talk about what that means. That almost rounds to 5, although I think it's, so it would be nice if it did, but we're gonna, let me see, let me see how close that was, if I can conscientiously do that. 4.8579, and that rounds to the 9. I'm not sure I want to go as far as 5. It would make this next part easier. Now, the way you use this, we're going to do in one of the next sections. Let's see, in 10.5, not 10.4, but we're going to be doing a distribution, and this is not part of it. I just want to show you why we do it. In the distribution, you put the mean in the middle, which was 38.5. And the standard deviation is how far you go on one side or another, minus 533 point, so that's 33.6, and this one's 43.4. Okay. So what happens here is one standard deviation this way and that way. Well, the total of this is 68% of all the data that was used. This is only showing 6 numbers. But if this was the result of, say, 1,000 numbers, it means 680 pieces of data are in between here and here. As you go further out, so I'm going 4.9 that way, 4.9 that way. If I go another 4.9, now this is a smaller amount. This amount's 13.5, this amount's 13.5. But that's 95% of all the data is within 2 standard deviations of the middle. And that's what they mean by standard deviation. If you're within 1 standard deviation, it's like the whole mass of data is mostly there. 2 standard deviations, almost all of it. A 3rd standard deviation is very, very small amount. It's at the very low end, very high end. Yes?
On the test, do you want us to graph it like that? Or?
Yes and no. You will have to do that, not for this problem, but for a different problem. I split these up as different things. For instance, I make this one problem, I make this another problem, which becomes one of the easiest things you can do since all I have to do is find the square root. And this kind of thing is a 3rd problem, not using these numbers. I give you other numbers so that in case you were wrong with these, you won't do it wrong on that.
Okay,
Yes?
because like on the homework there's found that you have to find like the relative theoretical probability distribution as in the experimental, as in the accepted value, as in the standard deviation.
I know.
It's like a page and a half.
I will not make you do all of
Okay.
that for one question. If I
Okay.
did, that would be about 5 or 6 questions
Okay.
together, because that's way too much.
Yeah.
I probably won't even ask all of those. It's just you want to know all of them because you don't know which one I'll ask,
Yeah.
because they're all just too big.
Yeah.
You know, I've actually thought about making part of the test questions sort of, maybe some of them being like, do some at home and bring them in, just because they're so big and long, but I haven't really decided yet. So, because I'm doing this a little differently than I've done in the past. Okay, the second page is the same exact thing, but it's with only 4 numbers. I would recommend for yourself, just try to practice this. I will show this all written out when I put it in Google Classroom, so you have a practice one. If I do give this to you on the test, which is probable, I'll make you do it one time, it would only be with 4 numbers. Okay, so it'd be more like this, because then it's not, I don't think it's unreasonable to do that much work with just 4 numbers. It would be with 15 as well, but there's not too much.
I'd rather write it out for some reason.
Yeah, and I actually like doing that, but with any more than that, it would be just too tedious and too easy to make a mistake.